Okay, so let's look at some special versions of 2 by 2 matrices, and we're going to start off with what we call a null matrix, also known as a zero matrix. Now, a null matrix or a zero matrix consists of zeros only, so it's 0, 0, 0, 0. That's a null matrix. What's the one thing that's worth noting about a null matrix? If you multiply any matrix, for example 2, 1, 7, 3, by a null matrix, your result should be a null matrix. So your result should just be a 0. Multiply anything by a 0, you get a 0. So that's a null matrix. The next matrix is an identity matrix. And we usually use the capital letter I to denote the identity matrix. The identity matrix is simply the matrix 1, 0, 0, 1. 1, 0, 0, 1. Now, what's so special about this identity matrix? If I take our identity matrix and multiply it by another matrix 2, 7, 1, 3, the result is the same, 2, 7, 1, 3. So if any matrix is multiplied by an identity matrix, nothing changes. You just get the same thing. 2, 7, 1, 3 just becomes 2, 7, 1, 3. So that's an identity matrix. Next thing we want to look at is determinant of a matrix. Determinant of a matrix. So if we have the matrix A, B, C, D, right? Our determinant for that matrix will be A times D minus B times C. So we look at this diagonal first. This first diagonal, A times D, and then we subtract these two. B times C or C times B, it makes no difference, right? So for example, if we had something like 3, 2, 1, 5, the determinant for that matrix will be equal to 3 times 5, that diagonal, the first diagonal, minus 2 times 1, the second diagonal. So this gives you 15 minus 2, which gives you 13. So that is the determinant there. It should be fairly simple. Now, last thing I want us to look at is a singular matrix. A singular matrix has two main features. Number one, its determinant is equal to 0. And number two, it has no inverse. We're going to talk about inverse, but for now, I want you to understand that a singular matrix has no inverse. It's impossible to get an inverse for a singular matrix. We will look at inverse in our next and last part of the matrices. So an example would be a matrix like this: 2, 3, 4, 6. What's the determinant here? The determinant is 2 times 6 minus 4 times 3, which is 12 minus 12, which gives you 0. This matrix has a determinant of 0. Therefore, this matrix is singular. Therefore, this matrix has no inverse. Matrix has a determinant of 0, it has no inverse, and it's singular. Let's just look at one tricky question they like. If the matrix 2, 8, 1, x is singular, find x. So how do we solve this? How do we solve this? We know that if a matrix is singular, its determinant equals 0, right? So if it is singular, the determinant should be equal to 0, right? So what's the determinant? 2 times x minus 1 times 8. So 2 times x minus 1 times 8 should be equal to 0. 2x, 1 times 8 is 8, minus 8 should be equal to 0. So 2x, if we take 8 that side, minus 8 becomes plus 8, is equal to 8. So 2x is equal to 8. If we divide both sides by 2, we get our x is equal to 4. So if the matrix is singular, it follows that x takes the value of 4. So let's try questions on these things, and then we do the very last part of matrices, and the topic is done.